Hey there, Math Hoppers! In this video lesson, we will learn how to perform operations on functions. Just like we can add, subtract, multiply, and divide real numbers in algebraic expressions, we can do the same with functions. So given two functions, f of x and g of x, and remember, this is how we read this. F parenthesis x is f of x. This could say h of x or k of x or l of x. X could be a different variable. It does not matter. I am a creature of habit, and I always write f of x and g of x. When we add f plus g of x equals f of x plus g of x, this will be very familiar to you. It is just like combining like terms. The only difference, we have functions now instead of simply expressions. When we subtract f minus g of x, same thing, f of x minus g of x. It is still just like combining like terms. The only two considerations you have are that order matters. It has to be f of x minus g of x, and we have to remember to distribute the subtraction sign. Just like when we have a negative in front of a set of parentheses, we have to distribute that. We have to remember to distribute that subtraction sign when we subtract two functions. When we multiply f times g of x, it is simply f of x times g of x. When we divide, we get f of x divided by g of x, where g of x cannot be equal to 0. Remember, we cannot divide by 0. It is not defined. So we have to consider that when we're dividing two functions. Now, speaking of domains, we are creating new functions when we either add, subtract, multiply, or divide functions. And we always have to state the domain of the new function. And to do that, we have to consider the domain of the two functions we started with. The reason being, the domain of the new function will consist of the x values shared by both functions. So if one or both of those functions already have a limitation, that limitation will be carried through to the domain of the new function. All right, let's add functions, and let's start easy. And what do I mean by easy? F of x is a quadratic and g of x is a linear, and we have done tons of work with quadratic and linear functions. So let's add f plus g of x. Remember, that's f of x plus g of x. F of x is x squared plus 3x minus 1. G of x is 3x plus 5. So when we add them, we simply put them together. It's x squared plus 3x minus 1 plus 3x plus 5. And now we combine our like terms. So let's look at our x squared first. X squared doesn't have another x squared partner, so it just comes down as x squared. There's nothing to add or subtract it to or from. Let's look at our linear terms, our x terms. We have a 3x and a 3x, both positive. 3x plus 3x is 6x. Now let's look at our numbers. We have a -1 and positive 5. When we add them, we get positive 4. So f plus g of x is x squared plus 6x plus 4. Remember, we already said the domains of quadratics and linear functions are all real numbers. There is no number for x that you cannot stick into either of those functions, right? So since the domain of f of x and g of x are all real numbers, the domain for f plus g of x is also all real numbers. All right, try saying these things 3 times fast. It's not so easy. When we subtract functions, remember we have two considerations, but let's use the same two functions, the quadratic and the linear. We know they both have nice domains. The domains for f of x and g of x, we've already stated, are all real numbers. So when we do f minus g of x, it is f of x minus g of x. Remember, that means x squared plus 3x minus 1 minus the entire quantity 3x plus 5. Notice that I said the entire quantity 3x plus 5, and then I put that quantity in parentheses. If you put them in parentheses, that should help you to remember to distribute that subtraction sign. Very, very often, we will distribute it to the 3x, and so we will say minus 3x and then plus 5. Remember, we have to distribute it to every term in that expression. Parentheses will help with that. All right, so don't forget, when subtracting functions, you must distribute the subtraction sign. Let's do that now. This is going to be a -3x and a -5. And now let's rewrite it without the parentheses, where everything has the correct sign. X squared plus 3x minus 1 minus 3x minus 5. Now we can combine like terms. Again, x squared has nothing to pair with, so x squared comes down. Let's look at our x terms. We have a positive 3x and a -3x. 3x minus 3x is 0, so they cancel out. There's nothing to write there. Let's look at -1 minus 5, or -1 plus -5, however you think about that. It's going to give you -6. So f minus g of x is x squared minus 6. Remember, the domains of both functions were all real numbers, so the domain of f minus g of x is all real numbers. Let's multiply, and let's change the functions just a little bit. Now we have f of x is x squared plus 5. So again, f of x is a quadratic. The domain is all real numbers. There's literally no number that you could not stick in and square and then add 5 to. But g of x is a square root function. And remember, square roots are limited to 0 and positive numbers. So the domain on g of x will be x is greater than or equal to 0, because we cannot take the square root of a negative value. So when we multiply f times g of x, we will do f of x times g of x. At first, it will look a little scary. We're going to take x squared plus 5, and we're going to multiply it by the square root of x. So I'm going to give you a hint that will help you throughout your math career. It is very, very often helpful to rewrite something, especially the square root of x, before performing any calculations. So before we do anything, we are going to rewrite the square root of x as x to the 1/2 power. Remember, roots are fractional exponents. So if you didn't know the square root of x was x to the 1/2 power and that the cube root of x was x to the 1/3 power, write that down now. Okay, so we rewrite that as x to the 1/2 times the quantity x squared plus 5. Now we are going to distribute x to the 1/2 power times x squared. We will rewrite that power of 2 as 4 divided by 2 so that we have like denominators. X to the 1/2 power times 5. Remember that when we multiply exponents with the same base, what do? We just add the exponents, and that's what we're going to do right here. So x to the 1/2 power times x to the 4 divided by 2 power plus 5 times x to the 1/2 power. Adding those exponents, we get f times g of x is equal to x to the 5/2 power plus 5 times x to the 1/2 power. Remember, we did have a domain limitation. So the domain of f of x was all real numbers. That was fine. The domain of g of x was 0 to infinity, where 0 was included. So our new domain for f times g of x is 0 to infinity, where 0 is included. Let's divide same two functions. So we're still going to do f of x is x squared plus 5, g of x is square root of x. We still have g of x with a domain of 0 to infinity, where 0 is included. F divided by g of x, remember, we will do f of x divided by g of x, where g of x cannot be equal to 0 because we cannot divide by 0. So let's think about that. I just said that the domain on g of x was x is greater than or equal to 0. So I said that it could be 0. But because we're dividing functions, it cannot be 0. Our domain is going to be further limited because we have a restriction on a denominator and we have a restriction on g of x. Let's look at it. We have x squared plus 5, that's f of x, that's going to be our numerator. We have the square root of x, that's g of x, that's going to be our denominator. Putting it all together, we get x squared plus 5 divided by the square root of x. Notice I didn't rewrite the square root of x here because it doesn't help me here. It helped me when I was multiplying, but dividing it doesn't, because this is one of the few times where dividing a lot of time causes less work for us. Most of the time we get dividing functions with operations of functions, we don't actually have to perform any division. We simply place f of x in the numerator and g of x in the denominator, and then we're done. There's nothing to actually divide. There's almost always a denominator limitation, but we save ourselves a little work in that we don't have to compute this. So let's talk about that domain limitation, okay? The domain of f of x was all real numbers. That wasn't causing us any grief. We don't even have to think about it. But the domain of g of x was from 0 to infinity, where 0 was included. And we have another limitation where we can't divide by 0, so g of x can't be 0. So the domain on f divided by g of x is 0 to infinity, where 0 is not included. Let's do another dividing functions. This time, the functions look easier, right? We have a quadratic and we have a linear, but we'll actually have more work to do here, because when we see operations with functions, most of the time we've already seen dividing polynomials, long division with polynomials. And so if you get two polynomials as f of x and g of x, you have to go ahead and take that next step and divide them. So doing f divided by g of x, we get f of x divided by g of x, where again g of x can't be 0. So even though our domains on f of x and g of x were all real numbers, because it's a quadratic and a linear, g of x has a limitation where it can't be 0 because it's going to be in that denominator. So we cannot have x equal negative 1/2, because if we set 2x plus 1 to 0, we would get x equals negative 1/2. All right, let's see what it looks like. F divided by g of x is 6x squared minus x minus 2 divided by 2x plus 1, where x, like I said, cannot be equal to negative 1/2 because it would make the denominator 0. Remember, we're not quite done yet. These two functions can be divided. So we're going to use long division to divide these two polynomials. So when we divide polynomials, our first step is to put it in long division form, just like we did in elementary school. So we have 6x squared minus x minus 2 divided by 2x plus 1. When you divide polynomials using long division, the nice thing is when you're actually doing the division step, you look at the first terms only. When we divide, we are only going to look at 6x squared divided by 2x. So 6x squared divided by 2x will give us 3x. Let's see what this all looks like and then talk about what we did. Okay, so we divided 6x squared by 2x, like I mentioned. We got 3x. So where did we place the 3x? We placed the 3x when we divided 6x squared divided by 2x. We placed the 3x over its like term. You have to position it over its like term. The next step, just like when we do long division normally, is to take what we got, the 3x, and multiply it by the divisor 2x plus 1. So let's do that. Multiplying 3x by this entire divisor, we see that 3x times 2x is 6x squared. Notice this is the same exact as the term above it. That will always happen for the first term. When you subtract these, the first term should give you 0. If not, something went wrong. There was a calculation error somewhere. So 3x times 2x is 6x squared. 3x times 1 is 3x, positive 3x. Now we're going to get ready to subtract. So we're going to place our subtraction sign, and just like in long division, we are going to subtract 6x squared plus 3x from 6x squared minus x. All right, let's show the result, and then we'll talk about what we did. Okay, when we subtract, be very, very careful. When you subtract 6x squared minus 6x squared, that's easy, that's 0. But negative x minus 3x is negative 4x. Sometimes people change this to an addition and then change all of the signs to their opposites so they don't make a mistake. You can do that. Or you can just be very careful and say negative x minus 3x is negative 4x. And then we bring down our negative 2, just like in regular long division, because we're getting ready to divide again. So what are we getting ready to divide? Negative 4x minus 2 by this 2x plus 1. And how will we do that? We're going to take the negative 4x, the first term, and divide by 2x, just like we did the last time. But we need some more room, so let's move this up. Okay, so like I said, we are going to divide negative 4x by 2x. We will get negative 2. We place negative 2 over its like term. So we place it over the constant in the dividend. Then, like we did last time, we say negative 2 times the divisor is negative 2 times 2x plus 1. And we get negative 2 times 2x is negative 4x. Negative 2 times 1 is negative 2. So we are subtracting the exact same thing. Negative 4x minus 2 minus negative 4x minus 2 is equal to 0. The 0 shows us that there is no remainder. My division is done. My answer is 3x minus 2, right? I know that because I have a 0 right down there, no remainder. Okay, so now let's put all together what we've done. F divided by g of x is 3x minus 2, where remember, x can't be negative 1/2. That was the limitation on g of x from last screen. So you have to keep that denominator limitation with you throughout. Let's do a few practice problems. Now we have f of x equals 5 divided by x, and g of x is 2x cubed minus x squared plus 3. All right, so if we're looking at domains, the domain of 5 divided by x just can't be 0. So it's all real numbers except for 0. And here we just have a polynomial, so all real numbers is our domain. We are going to first add. F plus g of x is simply 5 divided by x plus 2x cubed minus x squared plus 3. Remember, when we add, we need like terms. And 5 divided by x is simply 5 times x to the negative 1. So we have no like terms. We have an x to the negative 1, we have an x cubed, we have an x squared, we have a 3, which is technically 3 times x to the 0 power. We have nothing that we can combine. So since we don't have any like terms, we simply put the terms in descending power order so that they're in standard form. Our answer, 5 plus g, f plus g of x is 2x cubed minus x squared plus 5 divided by x plus 3. What is our domain? Remember, we can't forget to mention that. Our domain is all real numbers except for 0. We can't have 0 in the denominator of 5 divided by x, so it's negative infinity to 0, 0 not included, and 0 to infinity, again, 0 not included. Let's subtract them. Same idea. 5 divided by x minus the quantity 2x cubed minus x squared plus 3. So again, I put that quantity that we're subtracting in parentheses so that we remember to distribute. When we distribute, we're going to change the sign. Basically, that's what distributing a negative does. You change the sign of everything. Negative 2x cubed, positive x squared, it will become, and negative 3. So let's give us some more room. We've distributed. Let's rewrite with the correct signs. 5 divided by x minus 2x cubed plus x squared minus 3. Again, not a like term in sight. What do? Put them in descending power order. Sorry about that. But don't lose your signs, okay? Remember, 2x cubed was negative, so it's negative 2x cubed plus x squared plus 5 divided by x minus 3. That is f minus g of x. Our domain is exactly what it was for f plus g of x, where it's all real numbers except for 0. All right, one more. We can do one more. This time I have 1 divided by the square root of x and x squared minus 9, and we are going to multiply f times g of x. It looks worse than it is, I promise you. All right, when we multiply, it's 1 divided by the square root of x times x squared minus 9. Remember that we can write x squared minus 9 as x squared minus 9 over 1. And that way, we just multiply straight across when we multiply, right? We're multiplying straight across, and really they're both being multiplied to 1, so this is not hard. F times g of x is equal to x squared minus 9 divided by the square root of x, where x cannot be equal to 0. In fact, x has to be greater than 0. Why greater than 0? Because 0 can't be in the denominator. So I didn't say all real numbers except 0, because in the denominator there is a square root. So remember, the domain of a square root, the square root of x has a domain of x is greater than or equal to 0. However, we put that in the denominator. Now it has to be greater than 0. All right. I know domains get you. If you have questions on your domain or any homework problems or maybe a quiz problem from one of these modules, you should be subscribed to our YouTube channel, because that's how you submit your homework problems and you get a custom video solution. So be sure to subscribe, send us any problems you're having trouble with, and until next time, Math Happers, take it easy.